Okay, so we have a meeting today to talk about StreamRPC, and I made a Google Doc to sort of have an agenda, but it's going to be a bit chaotic because I'm chaotic. So, but let me talk through the start of the non-chaotic bit. So the problem Scalability wants to solve is that we observed that the way Gitly works now with gRPC, we have a bottleneck if we want to serve a lot of CI git fetch traffic, where the server is able to generate more data than gRPC is able to get off of the server. And so we ran into this because we made the pack objects cache, because the pack objects cache made it easier to generate git fetch response data. And we thought, okay, we're good now. And then it didn't work, or it worked, but it didn't work as well as we hoped. So we realized something else was wrong, and then we found this bottleneck. Then we designed something to address that, and that something is StreamRPC. And we started building that and submitting merge requests. And then at this merge request, which sort of shows things coming together, somebody started asking some good questions about the design and what we're doing here, and if we considered alternatives. And this meeting is here to have that discussion in a more efficient form, basically. And as far as I'm concerned, the goals are, what I would like to do is first to establish the StreamRPC design and what we're doing. So the thing that's already in progress. And then we can discuss concerns about that design and alternatives. But I thought it would be good to at least start with, to make sure we all understand what the thing that is now on the table, what it actually is, to make sure that there's not misunderstanding of what it does. Still making sense? Yeah, okay. Okay, so short background, how did we get here? We saw this bottleneck when we tried to serve a higher volume of git fetch data. The thing we were using was the GitLab or GitLab repo. So the GitLab or GitLab repo has a homegrown cache that reduces the fetch size to under a megabyte. And if you remove that custom cache, then the fetch size is 100 megabytes, and then we have a problem. But anyway, so that was what we observed in production. To understand if the problem was in gRPC, what I decided to do was to make a toy RPC system that did something different and see if we could go faster. And so that was the base of the experiment. So I built this toy where we have a web server, which plays the role of workhorse, and we have a proxy, which plays the role of prefect, and we have an RPC server, which plays the role of Gitly. And you could do a git fetch through that. And I was just throwing lots of parallel traffic at that and seeing where things broke down. So there was a toy implementation, and that seemed to work. And StreamRPC is basically an iteration on this toy implementation into something that I think can work in production. So it has logging, authentication, metrics, all that. And along the way, I did consider different approaches, but early on, I built this thing, and this thing apparently worked. So it seemed pragmatic to just, well, here's a thing that works, so let's keep iterating on it. So that's sort of where this design comes from. It's not an argument in favor of the design, but it explains a little bit how it happened. So I hope that's useful background for you. I mean, still making sense? Any questions so far? Okay, so
one question, can you maybe share the link to the document?
Oh, yeah, I think it's in the, I'll throw it in the Zoom chat. It's also the calendar invite. Where's the Zoom chat? Chat. Yeah, you're right. I see I'm the only one on the document. That's never right. Okay, I see Patrick's there now. Did everyone else who wants to be there? Yeah, okay, you're showing up. Okay. Um, so yes, Git bundle CSCDN. Yes, that's also a good thing to discuss. As far as I'm concerned, it's orthogonal. But what I wanted to start with is sort of a walkthrough of what the StreamRPC is going to look like, because um, we haven't built the prefect part of it yet, but the Gitly part is fleshed out enough that you can see what it would look like. So in this merge request, I have unmerged commits from Kwangmin's merge request with some commits on top that actually implement an RPC. And that's why I thought it would be interesting to look at this one. So there's the commit that adds the basic support for the RPCs, which mainly, I mean, some of it is tests, and there's a change in the server where we apply the middlewares both to the StreamRPC server and the gRPC server. But these changes are relatively small, I think. And yeah, so I actually don't think this commit is that big, but I shouldn't be talking you through it right now. But what this commit does is that it sets it up so that every Gitaly server can also accept StreamRPC connections. So it sort of takes care of that problem once, and then everything after that can use StreamRPC. And then if we go back to the commit list, there is some background changes to work with with some slight semantic difference in the RPCs. And then this is a commit that adds an RPC handler. And so what happens here is that we have backobjects hook, and this is taking the sort of the common core of backobjects hook and making a new RPC called backobject hook stream, which calls into the common core. And the RPC handler for that is at the bottom here. And that is just, yeah, a very, like it's a very straightforward handler. Like it looks just like a gRPC handler. We check if there's a repository. We call this validation function, which the other handler does as well. And then here we magically get a connection object from the context. And then we say we want to turn that into a reader, and we need a little trick to make sure that we can signal end of file. And we also use it as a writer here with IO copy. And then we pass these things into the common core of the RPC handler. And then it works and it comes together. So I guess what I'm trying to show here is that in this design, once that big MR that started the discussion is in, the further steps would look pretty clean and straightforward. And in the next commit, there's a client for this, which so in this case, the client is the Gitly hooks binary. So I had to make a feature flag mechanism where I check an envar. So if the envar is set, it goes into this handle backobject stream function. And yeah, it's a little bigger, but it's still not very big. So what happens is we build a request object from the repository in the arguments, which is the same thing you do in the case of gRPC. We define a callback, which would operate on the connection once the connection is accepted. And that callback copies standard into the connection, notifies the server that standard in is done, and then it reads the response from the server, from the connection object, and it writes it to standard out and standard error. So it's more or less just, well, this function is it's sort of similar to IO copy, right? So it's just copying bytes, and then this is the actual RPC call, which is kind of a lot of arguments, but that didn't make sense to. I couldn't really make the arguments go away, so it takes the context as an argument, which includes things like headers and feature flags and correlation ID. This takes the address, so this is a function that dials the address. We need to say what the RPC name is. We need to pass the request and the callback, and we need to pass the credentials middleware. and we could be using more middlewares, but in this case, we only need a credential middleware. So this again is enough to make the call on the client side. And what this would look like once we get to calling this in Workhorse is that this function and this function and this function would have to be exposed through the top level Gitaly client package. Right now they're in an internal package, but we could have a wrapper function that calls out to them. So that's how we would make the client usable on the Workhorse side. And creating a request object is done through the Gitaly PB proto package that we share anyway. And the nice thing is that this works, and I captured some flame graphs when this runs of a single clone on my machine. So this is the after and this is the before. And the effect is most visible in Gitaly hooks right now, because Gitaly hooks is only doing the Gitaly has to do 2 calls when you do a clone. Gitaly hooks is only 1, because Gitaly hooks is much smaller here. And you can see that all its time is spent here. Almost all its time is spent in writing to an OS file and reading from a netcon. And this appears to be some fixed overhead of a Go process. If you compare this with what happens in the case of gRPC, you see that here we're writing, and here we're reading from a netcon. So this is netcon read, this is OS file write, but there's all this stuff in the middle, including a lot of garbage collection, that is extra stuff that's happening because of gRPC that we don't strictly need to get the bytes from A to B. And what's interesting about this is that the same thing happens in Workhorse. So the moment and now I'm not talking just about StreamRPC, but also about solving the problem of this inefficiency, is that like roughly half of the CPU spent in Workhorse here handling this thing is also gRPC specific overhead. So the knock-on effects of this overhead spread throughout the system. And we also save time in Gitaly, but it's less obvious if you look at the flame graph, because it's still doing during a fetch you have post upload back and back objects hook, and right now the MR only fixes back objects hook, so post upload back still has the gRPC overhead. Questions so far? Is it does it make sense? Do you see how the pieces fit together? Do you see the benefits we're trying to achieve? Okay, well, that's good, because my main concern was to make sure that we all understood what this thing does and how it works.
Do we plan to mark somehow the methods that require a stream client RPC call? Because it looks a bit of complicated to call the StreamRPC methods from the client side.
Okay, let me pull up the code, because that makes it easier, because I'm not exactly sure which part you're talking about now. And if we look at the code, then we can. So
Yeah,
this is the client code.
Yeah.
So which part of this?
In the return statement, you need to use the full name of the method you wanted to invoke.
Yeah. Yeah, that is not so pretty. It's if we wanted to make that better, we would have to do code generation, because the RPC itself has a definition in I put that in a separate commit. It just has a proto definition. So the proto definition right now looks almost exactly like, well, it looks exactly like a Gitaly proto definition, right? We're also using prefect annotations with the purpose of making things work correctly without friction in prefect. So we could have annotations on here that say this is StreamRPC, and then we could generate client code, which is kind of what gRPC does too, right? You have the proto definition, and then the gRPC code generator generates a client. Actually, the client is in here. That's the server. Yeah. So this is the client, and gRPC, the gRPC protobuf code generator generates this function. And because for this project we only need 2 RPCs, it didn't make sense to me to write a code generator that writes functions like this. But if we have more of them and we want to do that, it is possible, because it's just the same thing gRPC does. And the funny thing is that because we're lucky with the request signature, the function signatures, we can reuse the function that was generated for the server by gRPC. Because, well, if you look at it, it takes an interface, a context, a function, and a gRPC server interceptor. So it's not coupled to, it's only coupled to interfaces, not to concrete gRPC types. But this generated function takes, well, it's a method on a concrete type hooks client, and we cannot add methods to the hooks client type because it lives in this package. Does that make sense, Pablo? So it's sort of...
I still don't understand. So we have a client, but we can't use it to invoke the method, yeah, because it's StreamRPC and we need to use our custom stream package to invoke it.
Yeah. So the way I would practically deal with that is to add methods to the Gitaly client package that are specific to StreamRPC.
Okay.
And I think
just wanted to get more details about how we can do that. Because to someone who will be interested in using Gitaly, we need to provide a good approach, or he can request methods of it, like a good client or so, like we do have right now, auto-generated code by gRPC. But for the StreamRPCs, we will need to provide our own implementation of the client then. Yep.
Yeah, and it's something that, from my point of view, the usability of the, I'm probably biased, but from my point of view, the usability of the current client is reasonable. But it's not as nice as the gRPC generated client. And that's precisely because there's no code generator. Like if there was a code generator, we could generate a nice, and you don't have generics in Go. So if you want to have a nice, a client that does more things just automatically for you, you end up having to use a code generator. And it didn't make sense to write a code generator just to implement 2 RPCs.
Yeah, fair enough.
And it's something we can still do later. Other questions?
One thing so what is the biggest performance improvement here? Is it that we're now allocating less memory, or is the biggest performance win that we now, for example, use zero copying semantics for when writing to the network?
I think it's, well, that's a question I don't have a good answer to. I think it's because we use less memory, but all I really know is that we have an existing thing, we have another thing, and we compare the two, and one of them has performance characteristics X, the other has performance characteristics Y. But to isolate the reason of why the one thing is faster, we would have to do more work.
Yeah, the reason why I'm basically asking is because if it was mostly limited by memory, by having to allocate so much memory, then The proper fix would probably be to fix gRPC to also have some kind of buffer where we can reuse messages so that we don't always have to reallocate, right? And if we were to fix that, then also all the other RPCs we actually have would benefit from this.
Yeah. The problem is that it's we talked about this on the thread about the codec approach, right? Because I think it's it's more or less the same idea. If we're sure that that is the fix, and if we can fix it like that, then that would be great, because then you have an automatic fix that is everywhere and you don't have to do anything for it. The practical problem I have with that is that I'm not sure what the fix should look like, so I can't even hack one quickly. And you know, I can I don't know, I can vendor the gRPC library and change things around. So we'd first have to do that, and then run experiments to see if that solves the problem. And then we have to present that in a way to gRPC Go where they accept it. And if you read that issue, then one of the problems that they mention is that for certain workloads, buffer use is bad, and it makes certain benchmarks worse. So it's not just how do you achieve reuse, but also how do you achieve reuse in a way where it's better for everybody. So the bar.
It's definitely a much more involved fix and probably going to take quite some time. I mean, first we have to implement the fix, then we have to benchmark it quite extensively so that we can actually propose it upstream. And then it's probably still going to take some time until there's another release. Did you see the MR, which actually did this already in limited context, where they did implement reuse, but which was reverted at a later point?
I saw some of them, but I haven't seen one that really made sense to me, because I saw something where they had a buffer pool in the codec, but that makes no sense, because you need to be able to put things back into the buffer when they're no longer used. So okay, we're now getting very specific about
the MR. I'm actually
sorry.
Yeah, sorry, but I mean, there was an MR which actually had this interface, and where you had an interface which actually told you when the buffer went unused. So when gRPC was actually done with the buffer, and then you could know, okay, now I can put it back into the pool, actually effectively solving that problem, and that you didn't know right now when to reuse it.
Right. I saw your link to a commit. I didn't see the MR that the commit was part of. So no, I don't know the bigger picture of what happened there.
Okay.
So if that's
the only reason,
why did it get reverted?
Because it did allow for the client to actually specify, or to, so it did basically allow the client to tell the server how much memory to allocate. So it's a simple denial of service.
Okay.
This can probably be fixed somehow, but I don't know how involved it would be. And probably it seems to be a little bit more involved. Otherwise, I guess that there would have just been another iteration of the MR. But why I'm basically asking is that the MR exists already, and it should, or it might actually show some performance improvements in some limited cases. So if we just try to use that MR and maybe port it to the current version, then we can maybe directly assess whether it's actually possible to use that.
Yeah. Yeah, so your idea is we benchmark Gitaly with, provide that we can, I don't know how old the MR is and if it compiles, but like if we can get the whole thing compiled, then we could have a custom Gitaly binary and then benchmark that.
Yeah, just to see if it actually has a benefit, and if it doesn't have any benefit, then we can just like quickly discard this idea altogether.
Yeah. Yeah, well, it's that's a fair point, because my main, but it at least if you can build on an MR, you have more of an idea of whether it can be achieved, right? If instead of so just for context for everybody else, there is an issue. One of the our best guess of why it works so much better to just use a socket instead of using gRPC is that every gRPC message does a memory allocation. And the way the gRPC Go library is organized, you cannot reuse those allocations because there is no way they get handed off and they get used asynchronously, and you don't know when the asynchronous thing is done with the allocation to tell you the site that does the allocation that it can reuse the buffer. So this is and this is a problem gRPC Go has known about since 2017, and they haven't still haven't been able to fix. So Patrick found the issue about this. So what we're talking about is can that problem somehow be addressed, and then would that be enough to solve to get the benefits we want? That was me just trying to give the background of what because I know Patrick and I have been going back and forth in this thread, but I don't know if everybody else followed that thread. Okay, that was sort of jumping the planned order of what are the well, I guess you could say this is about alternative solutions, but I also wanted to hear about concerns about StreamRPC. So we had we had Pavlo's question, which is maybe a concern, like what do we do about the verbosity of the client? Are there other concerns? So I think some of you were talking about Git push support on.
Yeah, I think that's one thing. Would be, of course, nice that we have something that works for both, so we could use it for both directions. But let's say, I mean, with the benchmarks we have and the amount of writes we have compared to reads, if we rule out pushes for now, I think the main concern that I would have is the fact that we lose status codes in Prefect, and that we have to also support this in Prefect.
Yeah.
Right now, we don't, for reads, really, I guess, do much in Prefect with the status codes, but there's been like previous work to observe the status code so we can identify, for example, broken replicas and quickly route the traffic elsewhere. Or there might be some other points where we would benefit from the status codes. So at least like when it comes to Prefect, that's one thing that I find a bit uneasy about, like losing the status codes.
Yeah. I cannot comment at all about what your plans are with Prefect. So thanks for telling me. Yeah, about the push versus pull thing, pushes are just my observation in practice is that pushes are much lower in volume than pulls, and it's largely because of CI, because humans do pushes and you do one push and then CI pulls it many times, and there's an amplification factor on how much that one human doing a push has many CI jobs doing a pull, and usually the CI pull is also bigger, a lot bigger than your push. It's always going to be bigger than your push. What happens in like the handbook repo is an extreme case where the fetches the CI is doing are 1 gigabyte or something. So somebody edits one line in a markdown file, so that's probably 10 kilobytes of push data. So we don't care about the gRPC overhead of allocating and freeing memory for that. But then we have a dozen jobs that download a gigabyte of data, and then there we do care. So this is a hard question, and this is more a question for you, for the Gitly team. Like I think that push is probably never going to be a problem. But if you think it is going to be the problem, or you want to talk about what that would mean, I'm also happy to talk more about that. But as far as I'm concerned, I would say it's out of scope, but I cannot decide that on my own. I think it's out of scope for the project we as scalability want to do, but for Gitaly, the question is also what you want in the long term with this thing.
Well, at least I haven't ever seen that pushes really are much of a concern, because I mean, the biggest difference between fetches and pushes is that fetches also happen internally, where we have a big network link like between the different machines. Whereas for a push, it's typically that it's a client outside of our data centers, and they are already limited by what they actually have as upstream. And because of this, I don't really think that it's going to be the same problem that we actually see for fetches.
Yeah. So what about detecting unhealthy replicas by observing status codes? This thing Sami mentioned.
Well, I mean, one can always, yeah, go ahead.
No, go ahead, you please.
Yeah, I mean, the how big of a problem it will be, I don't know. Of course, I mean, we'll still have status codes for all the other read RPCs, so we could still kind of trust the fact that most likely we're going to get other read traffic for the repository as well, and we can identify it from those RPCs. It's a bit of a workaround, but otherwise, yeah, the impact is, it's hard to say what it exactly will be. I mean, previously, back in the day, the idea was that we didn't want to wait for the health checks, and the health checks don't necessarily even right now really reflect the state of the disk. They just hit Gitaly and don't do much.
Yeah.
So the idea was that we could actually read the status codes and identify whether these RPCs are succeeding or not, and then decide based on that where the health of the Gitaly node in the background.
Yeah. So okay, so that's one concern, the status codes for health. You already mentioned possible mitigation is that there are also other RPCs which tell you about the health. So you could still get a useful signal from that. Any other concerns about? So you mentioned it has a piece in Prefect. So I can maybe talk a little bit about what I think that piece will look like, if that would help. So when trying to design StreamRPC, I was also thinking about how Prefect works, or how I remember that Prefect works, because I haven't worked on it for over a year. But what I remember is that it makes routing decisions based on the first request, and it looks up the repository in the first request, and it rewrites the first request, and it makes routing decisions based on that. And that is why this design also has a first request. It basically follows the pattern of, if you think of the post upload back RPC, it's a stream, but the first request is treated very, very differently from the rest of the stream, right? The first request has the repository in it and git config options and other stuff. And then the rest of the messages in the stream are used to exchange bytes. So because we have the method name and the first request, we have all the pieces to do the routing. And I also looked a little bit at how Prefect does its routing now. And if I understand correctly, it's a gRPC server with a not found handler. So it implements it's a gRPC, Prefect is a gRPC server itself that implements the GitLab server info, or it implements some RPCs natively that don't get proxied. And then all RPCs that are not implemented natively in Prefect fall into a not found handler. And then the not found handler does the proxying magic by looking at the method name and looking up. We have this auto-generated code that deserializes the bytes into the right type using reflection, and then we can rewrite the thing. So all that we could have the same pattern in StreamRPC, where the StreamRPC server has a not found handler. So on Prefect, there would be another StreamRPC server instance, but all requests would fall into the not found handler, and that would use the proto registry of Prefect to look up the RPC, the method name, to deserialize the message, to find the repository, to make the routing decision, and then make a subcall where it uses the same method name, it uses the rewritten message, and it does IO copy between the connections. So there will be a Prefect piece with this design, but it does. I think it does a very straightforward thing. It does the same thing we do with gRPC, just with a different protocol, but it uses the same routing logic. Maybe you
So,
guessed already, but this is what what I had in mind.
just a single question: does it already work with Prefect right now, or does it need those changes to actually work?
It still needs those
together?
changes because we.
Okay.
I have a commit where I created the not found handler mechanism at the StreamRPC level, and I played a little bit with moving things in Prefect around. But Wangmin has also been working on it actually, and his solution may look different from the one I came up with. So we've been exploring it, but yeah, we're not that far yet because it doesn't make sense to do a lot of work on that MR because if it depends on an MR that is still under review and not merged yet, and that we're talking about now. So that would be but the nice for our project, because we want to port back objects hook and post upload back. For back objects hook, we don't need the prefect bit. So that's why I started building back objects hook already, because that is never going to go through prefect. So that's just a matter of how we structured the project.
Yeah, but I mean, I definitely share the concern that Sami has with the status codes, because, for example, also the gRPC proxy that we have, which actually handles all the proxying to the primary and also to the secondaries, heavily relies on the codes to actually do the correct thing. I mean, as Sami said, we still have all the other RPCs which actually highlight whether something has gone wrong or not. But it might definitely be
the codes right now
an issue in the future. Sorry?
How does it use the codes right now, or are you talking about future use?
There is a piece of code
it already
that
does use the codes.
Yeah. Can you show? Can we look at that?
It already does use the code to actually decide.
Okay, so there was a piece of code that actually did observe the error codes. It basically just tries to figure out whether the response is coming from the Gitaly are within a certain threshold, and if not, then we consider it unhealthy. I think right now, when we change some of the routing stack, I think it's not hooked up right now. That's a bug, rather. But there is an existing piece of code that at least was in some points in use.
Yeah. Well, that would just keep working, I guess, because it would be on the gRPC path. But you would miss out on part of the signal for the StreamRPC calls. And yeah, otherwise the way I was approaching the prefect change was to try and disentangle a little bit how it's coupled to gRPC, but it wasn't too hard. I was working on the coordinator mostly. My basic idea was to add methods on the coordinator so that the coordinator could plug into the StreamRPC server and tell as a not found handler, and route the request using the methods for repository scoped accessors, or using the same lookups as those. Anyway, the status codes are one of the concerns.
Also, I mean, the gRPC proxy actually does frame-wise proxying. I'm not sure, do we still have frames in the context when you take away the socket?
Sorry, in which context? Are you talking about StreamRPC the way we're building it, or some of the alternative designs? I
mean, the current implementation.
Yeah. It doesn't do anything with frames anymore. Like it bypasses the whole. It never goes into the gRPC server because it injects at the level of transport credentials, just like in Gitaly. So in Prefect, a client makes a StreamRPC call. It goes into transport credentials. We see the magic bytes as a prefix, and we take the call away, the connection away from the gRPC server. And then it goes into a StreamRPC server, and it falls down to the not found handler. Then that talks to the prefect coordinator, and it says, I have a method name, I have a request object, I have some metadata. Where do can you decode this? Because it can decode it without introspection, without reflection. Can you decode this object, and where do we go now? And then the coordinator would do a proxy call. So it wouldn't use the gRPC proxy encode because, like you say, that is specific to gRPC frames and HTTP2. It would be a separate. It would be separate code, and it's relatively simple because it's just two Go routines doing IO copy on the client connection comes in, right? We rewrite the request, we make a call to a Gitaly server, and then we enter the callback, and then we have a server connection, and then we do IO copy both ways, and we wait until that is done, and then the handler is done in Prefect.
Okay, makes sense.
And yeah, it's the thing with the status codes. Another thing to consider is that I wanted, and I was trying to make this thing very minimal, and I figured if we want to have status codes, then we need to have some sort of framing or chop up the stream into pieces so that Prefect can see like, oh, this is a piece with a status code. So from the point of view of efficiency, I thought it would be nicest if that was not there. But we could also have a design where we say that the stream phase has some kind of framing where there is a final status code. And then you lose the benefits of zero copy, right? Because you need to do the framing and user space, but you still keep the benefits of not allocating memory.
The thing is, if we take that
Well, I mean,
approach, at that point, I think we can also go the route of multiplexing the existing
It's
TCP
more or less
connection.
it's very similar to multiplexing. I agree. Yeah. Because it is multiplexing.
yeah, because the main thing there was that with the multiplexing, what's unclear is how much do the optimizations of the zero copies and whatever the kernel can do for us benefit us.
You lose
and
those.
With the multiplexing, we lose those, and also with the framing.
Yeah. And this also goes back to what Patrick was asking about trying to solve the gRPC, the underlying gRPC problem. My gut feeling is that actually I think in most of the benchmarks, in the benchmarks, I didn't focus on zero copy. I thought zero copy was nice, but I mainly had it off most of the time, so everything was still going to user space. And I think doing very basic framing does not, I'm pretty sure, I know that does not add a lot of overhead if you do it right. So I prefer having the option, right, of zero copy, but I think the real benefits are in, the real benefits are in doing a normal IO copy and not this weird create a byte slice, put it in a struct, serialize it to protobuf, put it on the queue, wait on the queue, something else wakes up on the queue.
But I mean, I don't quite see why we shouldn't actually be able to use the zero copying if we have some kind of framing. I mean, if you, for example, use something like prefix encoding or something like that, then it should still be possible to actually have zero copies, I guess.
Well, but then you need to, you end up in a situation where you need to write the prefix, the little header, and then you can do a zero copy thing to copy the data, like with splice or something, or but then that's that is. I don't think that would be my first iteration because you need to write Linux specific code for that. The nice thing about zero copy where you can just use the network connection is that it's a Unix. It's a very, it's not used a lot, but it's a very basic Unix thing and it's going to work everywhere. And
I think the main thing is that if we have to do the framing in user space, we can't use send file, so the kernel cannot just copy this.
Well,
right.
It's not necessarily that bad because Yeah, no, maybe not, but I was trying to use send file the other day in that merge request I showed you. I was sort of waiting on the review. I thought I'm just going to add send file. Why not? And I got it working, and then I thought, okay, let's do some benchmarks, and they were sort of the same. And maybe the benchmarks weren't that great, but I thought I can't really sell this, so I'm taking this commit away. It I think that IO copy through user space is really not that bad. And it is like, yeah, you can sometimes really save CPU if you don't have to do it. But yeah, if I have to choose, the biggest win is not doing this weird thing with allocations that you throw away. Just having a straightforward. I'm also reminded a bit of Patrick of the thing you observed with the pipes and the cat file, where having a weird IO pattern is not good, and just doing IO copy or doing IO copy with very basic prefix framing, which by the way we have to do for a PECOP6 hook anyway, right? Because that's a standard out in a standard error stream, so we frame that already, and that gets de-interleaved by the client.
So I think from my side, if we would consider the status codes to be some sort of a concern, and then we would start framing, then the question from my side is that whether we would be better off multiplexing the whole TCP connection. Would it be simpler than implementing another protocol on the side?
Maybe.
And we can either use existing multiplexing methods we have, or we could possibly do something that fits better for the use case and doesn't have a lot of extra stuff included.
Yeah, I think I don't have a clear indication that Yamax is eating up a lot of. I mean, you can see it, but I don't think it's eating up a crazy amount of CPU. So it could be that something with Yamax is fast enough. Yeah, and that might be easier than trying to fix memory allocation in gRPC. Although, of course, that is like if that problem really is fixable, and if that really is the fix, then there's like it's good karma to just make gRPC better for everyone. But yeah, I would say that with a multiplexing approach, there's probably less uncertainty in that we get the outcome we want. Because with the moment we try to fix the library, there's the uncertainty of, can we fix the library in a way that upstream accepts, right? And if we build multiplexing underneath gRPC, then it doesn't really matter anymore how gRPC works. The problem with multiplexing is that I think it's, in my mind, it's more, I find it harder to wrap my head around. So if we go that way, maybe Sami, you could help us, because you've worked on, if I see correctly, you worked on that with backchannel. But yeah, I think that's also valid.
Yeah, and the main thing I think, like between the different side connection approaches, is that with the TCP connections, we had the problem that we might between Gitaly restarts and so forth, we have a lot of problem basically traveling through the different load balancing points.
I think the problem, once you have
within the same TCP connection, we could avoid those.
Exactly. The problem is that two processes need to talk to each other. And if once you have established a connection, you know that there is a process on the other end. And if you need to establish two connections between the same process, that is actually, I think, a unusual design requirement. Usually, if you have multiple processes handling requests, it doesn't matter which process handles the request. That is just a much saner way to design your system. So concern about status codes. It would be nice if we did have status codes, because Prefect wants to use that to see Gitaly health. Multiplexing would solve this problem because it's has the gRPC status codes. So maybe we need to
There's still
explore
one more topic I want to talk about,
yeah.
Which is the bundle URIs. I'm not sure if you're actually aware of it, but Ava is currently implementing support for bundle URIs natively in Git, where bundle URIs is a protocol where the server can tell the client that there are specific bundles which can fetch from a CDN, which effectively makes your pack file hook completely obsolete because we don't need it anymore because it's built natively into Git itself. So
I
as soon
don't
as
think
we have
so. I don't
that,
think
do
it
we
makes
actually
it
still need
completely.
the
I don't think it makes it completely obsolete because it solves a different problem. It reduces the amount of data you need to transfer. It does not solve the problem of having lots of identical requests coming in. So the PackObjects hook is deduplicating PackObjects processes, and it doesn't really matter how much data they generate. It's just that if within 5 minutes you have multiple requests that request the exact same data, then we run only one process. And
well, it can still solve that issue by creating incremental bundles, because the bundle URI protocol that is actually implementing also is able to actually list multiple bundles where the bundles have different contents. And if you only have incremental bundles, then the client can pick the correct bundle for himself so that he knows, okay, I only need to fetch that small bundle. And then, yeah, then we can just serve it from.
I think of it. I think it is a very valid approach, but I think of it as complementary. I don't think it makes it not worthwhile to make sure that we can serve a lot more traffic, fetch traffic from a single Gitly server, or from a couple Gitly servers that are doing read replicas.
Okay, I mean, solving the underlying issue definitely is worthwhile, I guess. So yeah.
Yeah, I think solving both it makes sense.
Just out of curiosity, how would it work actually in practice? So basically, as far as I understood, usually when you do fetch, Git would calculate the most efficient pack to send to the client, right? So what would those packs in the CDN be in this case? Would we actually send like the packs to CDN and just tell the client to download them from there, or do we already pack and then the client gets something less optimal pack basically? Or
Less optimal. That's what it means in practice. You have a couple of less optimal things that you can serve from a CDN, so very efficiently, and then clients do incremental fetches on top of that. And that's the reason why we can handle GitLab or GitLab CI traffic, because we have an ad hoc implementation of that. We have a CI, the CI equivalent of a cron job that does a shallow clone of GitLab or GitLab and tars that, creates a tarball out of that and puts it in object storage. And then every regular CI job, before it does a git fetch, it has a script that is committed in the database text box. So this is really horrific. That downloads that tarball and unpacks it, and then it runs a git fetch on top of it. So it's doing an incremental fetch. And because that tarball gets updated frequently, the fetches are, hi Pavlo, thanks for joining. Because that tarball gets updated frequently enough, the fetches stay small. And if something is wrong with that tarball, or if the CDN is out, then the server has a serious problem. Well, it has a less serious problem now, but it would still have a problem because of the gRPC bottleneck. But what we saw in December last year was that when there was things wrong with the CDN and when there was no cache, then that would just completely knock out the Gitly server with the CI traffic. So what do we do now? I think that we have two proposals of different things that you might want to see benchmarked. So one is Patrick was saying the merge requests with the memory reuse, and then there's the other question if multiplexing would also give us the benefits we hope for. From where I'm sitting, multiplexing looks like a safer bet, because well, we don't have to upstream something. There isn't the question like how and when do we get to upstream this, and we've done it before with backchannel. On the other hand, I don't know the problem well enough to just I don't think we can literally take what backchannel does and do that. So there's still a puzzle piece there. Because
I mean,
go ahead.
to me, it rather sounds like the multiplexing code and also the code that you've currently written is like the short or midterm solution, while fixing gRPC would be the long-term solution, because it would actually fix all our problems. Or, I mean, not all our problems, but all the problems we have actually with memory allocation.
Yeah. Yeah. That's fair. And from our point of view, we're doing scalability is not long-term working on Gitaly, right? That we work on different things. So we have a project going on now where we're trying to make this problem better. So trying to solve the problem in gRPC is not well, it would be a completely different project for us. And I'm not sure we would be doing that.
Yeah, I mean, it was still nice to actually see whether it's possible to like briefly rebase the MR that I've been pointing out and see whether we can actually reap any benefits from it. If it is not possible in a reasonable amount of time, then we may still say, okay, this is not a short-term thing that we can actually benchmark. And then we can still go ahead with the other solution, I guess.
Okay. And the other solution being?
Basically what we're implementing now.
Okay. Even though that doesn't have status codes?
Well, I mean, yeah, with the status codes on top, because yeah, as Sami said, it's going to be increasingly important probably, or it might actually just like paint us into a corner if we don't have them. And that's probably something we want to avoid.
Okay. It's a bit
happy about that.
No, I'm not really happy about it because it's a lot of work, and it would be a lot of work to redesign what we have now to have status codes, and then we have to think hard about whether we would do that by adding status codes to StreamRPC or whether we would do that by using multiplexing. So just figuring that out is going to keep us busy for a couple of weeks, and then running an experiment on the side with gRPC. We have yeah, I'd rather not do both because it's just having to change everything now already is a lot of work. So I prefer to pick one approach and say we spend the time on that. Well, if you could prepare something that uses the gRPC patch, then I can run the benchmarks on that, right? Because but having
that's fair.
Yeah, but diving into how to do that while we're also trying to accommodate and the requirement for status codes and trying to figure out how to do that, I think it stretches us a bit too thin.
Yeah, that definitely sounds fair to me because I'm also the one who is actually asking for that. So I can definitely prepare something, and then if you do the benchmarks, I'm happy with that.
Yeah. Okay. Guangmin, what do you think so
Yes,
far?
yep, I think that's my sense that we have to like match the correct situation to, well, actually to whether it benefits us or not. And then we have to think about the other solution and then just compare two of them at once so that Yep, I think that makes sense.
I think we should go back and think about how we want to implement status codes, and then preferably pick one thing and see if that still does the job, or maybe two, but yeah. Okay, then we know what to do. Thanks for your time in the meeting.
If you need any assistance with the multiplexing approach or so, or so forth, I think I can also.
Thank you.
Try to
we may ask your help for that, and thanks for offering your help. Yeah. Okay. Well, thanks. I'll record. I don't think we said anything that can't go public, so I'll record this. I'll upload this and put it on the YouTube channel and share the link in the Gitly channel too when it's there.
Yeah, thanks.
Okay. Thanks, everyone.
Thank you. Bye.